This is like your homework. It's a classic law of sines case, right? We've got angle side pairs, perfect for the law of sines, right?
Yep, law of sines.
3 sig figs IB likes on any rounding if it doesn't say. Should be pretty quick and obvious right away that this is 70, and then you can set up your angle side pairs and solve. Did they do a good job? Just check their answers as you check your answers. Okay. All right, let's move on. Thank you, Cam and Lisa. Okay. All right, so we actually would like to say a little more about the law of sines today is what we'd like to do. Let me just give a flying overview. This is not necessarily something like you have to take notes on if you like. This slide right here, I just want to tell you where we are and where we're headed. Certainly any right triangle, you've got some nice equipment to solve right triangles. But in general, if you have a triangle like, what kinds of triangles can we solve? Like the one in the warm-up you just saw is a good case of angle side angle, or angle side, I think is what it was in the warm-up, just like this picture, right? The point though is if we give you 2 angles in a triangle and any side, you can get everything else. Do you agree? I mean, in the homework last night you were doing that on some of the law of sines problems. So that's perfect. If you're ever given that picture, if you've got 2 angles and a side, any of these cases, then the law of sines just works like super well. Wonderful. Tomorrow we'll discuss something called the law of cosines, which will help us solve the following 2 cases, either SAS, which is what I'm showing you here, or also SSS, right, where you're given 3 sides. Already you can think, okay, well, side, that's not going to really go well for me with law of sines, because I need, for law of sines to gain any traction into using the law of sines, I need like an angle side pair, right? But there is one case that we'll talk about that tomorrow. Or just like I said, I'm giving you like an overview of where we are and where we're headed tomorrow too. So law of cosines, maybe you've thought about it before, but we'll talk about it a little bit tomorrow. There's not much to say about it. And then this is the one that we'd like to talk about today. Like all of class today is devoted to this case. It's called the SSA case. Is it how we're going to name it? Is that okay with you? Where we're given 2 sides and one of the non-included angles. Okay? Now you can already see why this is going to be fruitful. This is law of sines, right? Why this is maybe still a setup for law of sines. Because we do have an angle and opposite side pair, right? So it is actually well suited for the law of sines. Now some of you might be screaming, I hear mumbling already. Right? That this is like not one of the ones I remember from geometry. In fact, like we were specifically warned against it. That fire and brimstone would come down on your heads if you tried to prove 2 triangles congruent via SSA. So I agree with that. So we do have to be a little cautious. And maybe already with this picture I've drawn it in such a way that you suggest that maybe there's another option for how that triangle might look. But we actually don't have to be, I mean, with caution, we can move forward actually. We can actually tease out some of the issues with that. Okay, so that was the flying overview. Here's a triangle. Do you like it? I've named it in like kind of the traditional way. Big letters for the angles, little letters for the sides, opposite the corresponding letter for, right, capital, lowercase. You guys used this convention, I think, before in geometry maybe. Do you understand that by little a, right away, if you know where big A is, then you know where little a is, okay? Hopefully that convention makes that clear. And then I'm drawing h, the height. Let's call this length in yellow, this altitude that I've dropped, let's call that h. And if you were given, say, side length b and angle a, could you come up with a relationship between h, the yellow length, b, side b, and angle a? What would it be? Keeping in mind that, like, really, if you block off this side of the triangle over here, you're looking at like a right triangle over here, aren't you? Yeah. All right. So that being said, go back to like trig 101. What's the relationship between h and b and a, angle a? What is it? Someone's sine of a is equal to H over B. Okay, so if someone told you B and A, you could calculate H in particular. What is H? Just for a second. Yeah. So in particular, is it obvious that H equals B sine A then?
Yeah.
All right. I just want to make sure that's clear in your mind. Now, again, just as a matter of convention for our lesson today, as I go through this, we're going to kind of go through a flow chart a little bit here. Let's just suppose, for the sake of discussion, that the two things that are given are side A and side B. And the angle that's given is angle A. Is that okay? That is, it's not angle C. It's not the included angle. It's one of the other two angles. So in the picture, that's this angle, this side, and this side are the things given. Okay. Now, with that convention in mind, let's suppose those things are known and the other things are unknown. Let's move into case 1. And that's where the angle given is obtuse. Two sides are given and an obtuse angle. All right. So imagine if I were to construct this, this is how I would do it. I would draw a ray of an infinite length on my paper. And that would be my side C. And the reason I drew it an infinite length is because yet right now I don't know how long it is. And then I would measure out the angle that was given, angle A. That I know. It's got to be exactly this side. It's some obtuse angle you gave me. It's 100 degrees. I'm going to make it 100 degrees. And then I would maybe draw a line. I'd swing a compass, and I'd mark out this length, which was also given to me. This length, little b. It was given to me. It's got to be this length, this long. I'm not sure how long this side is, but I do know everything else about this picture. The other thing that was given to me is little a, the length of side A. And if someone gave me the length of side A, how would I deal with that? I would set my compass maybe open to that length, and then I would swing my compass until maybe it would hit this side, right? Because I'm not sure where it's going to go. I would stick my compass here, and I would swing it, right? And if A, that is the length of side A, is greater than the length of side B, then that will go really well, right? We'll get side A sticks here. Like I said, maybe you swing a compass and it hits there. Yeah? Does that make sense? Perfect. No big deal. Do we get a triangle? Yeah. In fact, we might even go out of our way for reasons you'll see soon. That we get one triangle only. Okay?
So we're going to have to use a compass?
No. You'll know if A is greater than B, you'll know that. I'm just thinking, in the compass in your mind, you would know that would hit. That would be good. What if A was less than B, though? What if little a, side, this yellow side I'm about to put in, what if that was less than the length of side B? What would happen as you swing your compass? Yeah, I mean, here, I have the picture, right? It's like, I can't reach. It needs to be at least as long as B, right? You could swing your compass all day long, and it won't reach. It will never hit this ray down here, will it? Right? So in that case, I mean, it's very easy to write this on paper and not know the difference, but as soon as we start thinking about drawing these, you're like, there's not even a triangle here.
Isn't the other issue that in that case, the angle A is...
Yeah, we're going to think about what happens if angle A is acute, too, in a minute here. But if angle A is like 100 degrees and side A is 7 and side B is 3, then we have a triangle, don't we? That's case A over there. But on paper, if I asked you solve this triangle, which I would do, I would say solve this triangle. It looks just as innocuous on paper, doesn't it? Both of those look like wonderful problems. But this one, if someone says solve this triangle, you say, I'm sorry. It's not a triangle. It doesn't exist. It doesn't even exist. You can't construct a triangle like that. Yeah, Judith.
If you say that you know if the triangle interline with the triangle at 180,
Yeah.
and the side opposite to the largest
Yeah.
angle over the largest side, that can't be true.
Absolutely, right? Is this? I mean, like I said, we don't need you don't need me for this, okay? Let's just be clear. You know this already. That the opposite side of the biggest angle has to be the biggest side, and that's contradicted by this second case, right? So one way or another, draw a little picture, convince yourself, remember something from geometry, and to realize that there's no possible triangle in that second group.
Would you get to like how would you get if you just brought the compass out more?
Yeah, but this is, we're setting, someone gave me the length A. Like they told you this information and they said, make a triangle, go, have fun. And you're like, sorry, I can't, right? You can't because I'm forcing you to set your compass to a length of 3. And you swing and you don't hit that ray at all. Okay. So yeah, more interesting things happen now if A is acute, if A happens to be an acute angle. So here it is. Here's a picture of an acute angle for A now. Now we'd like to do the same thing. I'm giving you a fixed length A, and you might do the same thing. You might be like, okay, I'm going to set my compass to a size of A units, and I'm going to center it at C and swing. Yay! What at the very least has to be true in order for you to be able to hit the ray down here? What has to be true about A? I mean, it has to hit, if we're going to have it hit this side, I mean, how are we going to, when would it be too short? That is, right? We want to determine the minimum required length for A to even form a triangle at all.
It's less than whatever.
And there's a big giveaway up here. If it's less than H, then that's a little bit of a problem, isn't it? H is not just the height of the triangle that's in our future. It's also it also represents the minimum required length for A, doesn't it? It's the minimum distance away from C, the minimum distance away from the line. So again, we're in this case, we're in the case, right? We're in the T-Rex case, yeah. We're in the we can't reach case, yeah? Now, that might be easy to see in this picture, but let's just say right now that in order to realize that we're in that case, then there are no triangles. It's not quite as obvious as the last one, right? This means you need to know whether the A value I gave you is less than the height or not, which means you may need to compute what the height is. I didn't give you necessarily the height. I'm just giving you sides A and B and angle A. But that's okay, because we know the height. It's B sine A, right? So that's not a big problem. We might have to compute that and then compare, and then we would know which case we're in. All right, well, what if A is H, though? Then will it reach?
Yeah.
Yeah, in fact, it won't just reach, and it will form, yes, it will form a triangle. It'll form a very special triangle. Yeah, it'll just exactly reach. Right here's the compass. Sweeps by and just barely hits. Yes, we got it. We got it. And yes, it's not just any triangle, it's a right triangle. Okay? So yes, there is one triangle formed. And already maybe you see foreshadowing of what's about to happen and what's going to become interesting in a second. What happens if A is longer than H? Maybe, how about by just a hair? It's not a right triangle, that's true. But then wouldn't you have, well, let's see it. If A is greater than H, let's draw this in here. That means we're swinging a compass that's just a little bit longer than H. Then we have, say it, Teo?
So it's the C case, so we have two possibilities.
We have
a really small C or a larger C.
Yeah, we kind of have two possibilities. I'll subscript them. We have two possible places for this other side to land, right? Just to make it clear, we do have two triangles, and I'll highlight them. There's the first one. That's one option. Do you agree that this yellow triangle does in fact have this angle, the required angle? This side B and this side A, those are all exactly the same that we need. We need those all to be exactly what they are. And here's the second triangle I'm highlighting. Do you see it? And it has all the same properties that we desired. It still has this same angle A size. It still has this length side B for side B, and it has this same length for A1 and A2 here. Sorry, I shouldn't have subscripted them. They're the same length, aren't they? Okay, and then just to make this clear, let's actually click on this. I whipped up this applet for us here. Actually, here, let me. I pulled it up here. All right. Just to show. Okay, so right now I have angle A given I set it to 30 degrees, but we can slide this back and forth and do whatever we like and make it something else. And then I have side B fixed at a length of 5, but again, we could change that assumption. These are the 3 given things that someone is handing us. We're asking how many triangles are there. If side A is 2, then we're sweeping a compass centered at C of radius 2, and we don't get any triangle. You see it? I mean, you can see it from the picture. Why do you know that, though? If you were looking at this on paper, that's nice that this shows that maybe, but how do we know that that doesn't reach? No, it's not necessarily true. I mean, if A is less than B, that's like still up for grabs. We don't know. Yeah. Yeah. And what is H? Do we know? It's in the letters here, B sine A, right? So what is that? If B is currently 5 units long and A is 30, even without a calculator, I think we can say what that is. It's 2.5, right? It's a 30-60-90 triangle. This is half as big as this, isn't it? So, yeah, if A is 2, it doesn't reach. If A is, so what happens? So if A is 1 or 2, but as soon as A is 2.5, bam, we have a triangle. 1 triangle. If A is 3, then we have 2 triangles. Do you see them?
Now.
If A is 3.5, we do. All right, and then now we haven't yet talked about. So this is the ambiguous case. It could be either triangle. We haven't talked about the third case yet, or the fourth case. What happens? What happens as we get bigger here? What's going to happen as I slide that past what critical value?
If you get past.
Yeah, the length of B. As A goes longer than B, what happens? What's going to happen? I don't want to show you yet. What's going to happen? Yeah. There'll only be 1 triangle. Let's see if that's true. All right, they're equal, right? They're equal, and there's only 1 triangle. The other triangle is like this degenerate one, right? So there, now we have A equals something bigger. You good? Make sense? Okay. So only 1 triangle there. Oh, sorry, I didn't draw the height in there. There you go. 2.5 is the height. Anyway, we can play around with this. It's fun. Okay. We can make B bigger. We're having fun now. All right, let's go back. So one thing I didn't highlight on this slide. Is this piece right here. We said, what happens if A is greater than H? And we talked about, oh, there will be 2 triangles. And we've just highlighted now that that's actually, if A becomes really big, though, bigger than B, then we're actually in another case. It's only 2 triangles when we're in this special case right here. So the last case is if A is greater than B, and we just highlighted that with the applet, we only get 1 triangle, right? All right, so that's like the flow chart. In practice, though, I'm not probably using the flow chart. I'm actually just kind of thinking about it, maybe, right? Because in a minute, I'm going to switch letters on you, right? Yeah, you know, and you're going to be like, wait, no, A always has to be the swinging side, or else I'm messed up. Well, I don't know. What are you going to do when I hand you triangle RST or whatever, right? You're just going to be like, convert it to. What if I give you an angle B in triangle ABC though? Then you're gonna be really messed up. Well, A is B now, and C is A, and B. All right, so let's play around with some of these triangles. My first question is there even a triangle at all? And so right now I'm not asking you to solve these yet. I just want to figure out which case are we in. Now this first one I think does obey the rule, the naming conventions that I've already assigned. So today, but we're going to switch it up down here as we go down the page. So I'm drawing this, is what I'm going to do. I'm going to draw this. Here we go. Here's angle A. Here's side B. It's 8 units long. We don't know how long this side is. Is side A, which is 12 units long, going to fit in there nicely? Yeah, I think that's going to be a 1 triangle case. Do you like my picture? Where was I on the flow chart? I don't know. Who knows, right? Draw a picture. Think about it the way we did. All right. Part B here. We've got an acute angle for D, 49 degrees. And we've got side E is 41 units. We don't know how long this side is. 49 units. 41 units, excuse me, whatever. And we're trying to figure out whether D equals 26 is going to fit in here. Little d, side D, is 26 units long. And that's kind of a little bit of a, I mean, we can go by our gut feeling, or we could actually compute the height. What is the height going to be? Yeah, it's this side times the sine of the angle. So 41 sine, someone do that on the calculator because I don't know the sine of 41. I don't know, actually I probably could estimate. I know the sine of 45, you know, maybe we could estimate. What does it come out to? 30.9? 30.9 units long. So will this work?
0.
Yeah, so no triangle because D is 26 units. Doesn't even reach. We're in the T-Rex case. Yeah. Right? Doesn't work, doesn't fit, 0 triangles. No, or you can write
for
none.
This one, if it had reached, then it would be 2, right?
Yeah, if it was like 32 units or something. Exactly. All right, next one here, we've got angle C. I love it when they're obtuse. Okay, we got angle C right here. Side A is 15 units long. This is side A. And side C, I'm going to try and stick in there. It's 6 units long. Yeah, it's sad day for this triangle. It fails to exist. I'm sorry, triangle. You fail to exist. Side, what about part D here? We got angle Q, which is, this is 30 degrees. 30 degrees is angle Q. This is 16. Angle, this is side P. Thanks, guys. Stay with me. We don't know how long this is. This is 16 units long, side P. Tell me what's going on, somebody.
It's a 36 and 90 triangle, so it's going to make 1.
Yeah, and this is 8 units long, which is also the height, right? So there is only one triangle, and it's a right triangle. Do you see how this works? All right, next one, 23 degrees. Stay with me, stay with me. Angle M. We got side length here. We got n equals 3 over here.
Yeah, that can't work.
What's going on there?
It can't work.
It doesn't work because
We can figure out what the height is.
It can't work because
it
they
can't
both
work
have to
because
be
sides N
45.
and M are the same length, so they'd have to be 45.
Yeah, they'd have to both be 45.
Yeah, it would have to be
How about
45.
how about we draw M in here? I think we're going to be okay.
What?
And we just get one triangle, don't we? It's an isosceles triangle,
Oh.
right? The height, you can compute the height. It'd be 3 sine 23. Figure it out. But definitely 3 works.
Wait, doesn't that get this?
So that's one triangle.
Yeah.
Shoot, I hope the last one's ambiguous, or else this is kind of silly set of activities here. Let's just assume the last one's ambiguous. Let's see here. That's 10 degrees. That's angle S. Sorry, it's a little hard to see down there.
Oh.
10 degrees. The opposite side is S. This side is M. That's 150 units long. What's the height? Can someone compute that? I think we're going to be good. 10 degrees is not very much. 150 sine 10. Someone compute.
26.
Yeah, so like, is 100 enough? I think so, right? So the height is about 26, approximately. So I think we have a triangle here, okay? And there are 2. Why? Because it's still less than 150, right? We can swing into both positions. Yeah. Isabel. It's 150 times the sine. It's this side length. Whatever that side length is. The one next to the angle. Times the sine of the angle. Go back and draw. No. Yeah, go back and draw the picture. Alright, it sounds like you guys are packing up. I would have loved to work through an actual example with me. I think you'll be okay. The one realization that's going to help you, if you guys would just listen for the last few seconds here, could I have your attention? Can you hear me, please? The one observation that you're going to need to know as you're solving these is the following, okay? if you have two triangles, you have the following picture. You're going to solve for both sets of triangles. And the thing you need to realize is that if this side swings from here into here, then this angle you'll be able to get. It's not a problem. You'll see. But what's the relationship between this angle and this angle here? That's like the one big aha moment that you're going to have.
Oh, you're gonna say it's supplementary.
How can you prove they're supplementary?
Because if the sides are the same, then that
What's true about this angle here?
the angles are congruent.
Yeah, these two angles are base angles for an isosceles triangle there. And therefore, since these are supplementary, these will be too. Alright, so we'll work through an entire problem tomorrow when you come in. This gives you a nice overview.